In this section, we're going to get into the chemical reactions. There's a lot of chemical reactions that we can go through, but we're just going to split it up into two different sections to make it a little bit easier to keep up with them. So in this first section, 8.2, we are looking at just the synthesis, decomposition, and combustion reactions. So let's go ahead and look at some of the finer details that go into each of these different types of reactions. Before we do that, I just want to remind you that remember that for chemical reactions, we're just talking about the breaking and making of new bonds between different types of substances. These can be different compounds, they can be elements, but the idea here is that we are changing the reactants that we start with, we are breaking their bonds and creating new bonds to make new different products. And so we can have different types of chemical reactions, and we can tell them apart by what reactants are being used, what products get formed, and just the overall process of what is happening. So we're going to be using that information to categorize our different types of reactions. And again, the three types of reactions in this video are the synthesis, decomposition, and combustion. Now, for the synthesis reaction, what's happening here is that we're taking two or more reactants. This is what we start with, and they're combining to make a single product. So the general form that you'll see on these is that the reactants that we start with, just in general terms for this example, is that we can have reactant A plus reactant B, and through our chemical process, they will combine to form a single product. Now, notice that in this case, AB is a bonded compound. These two elements or substances are bonded chemically. We've created new bonds between them, and they're being held together. So this is just the general format that these will take. So it's what you look for synthesis reactions. Let's actually take this and put it into a real example. Let's talk about rust. So rust forms whenever there's iron metal and it reacts with oxygen. Usually this oxygen comes from the air and it forms rust. Rust is chemically different from iron because it has combined with oxygen. And here's the full chemical reaction that we have for rust, where we can take our rust element and it's combining with oxygen, usually from the air, to create a new compound. This is ferrous oxide, which is what we know as rust. It has that characteristic reddish color like this rusted out car. When it comes to decomposition reactions, what's happening here is that you start with a single reactant, and through our chemical process, it actually breaks down into its smaller pieces. So the general form of these decomposition reactions, again, is that we start with a single product, or with a single reactant, and we end up with two products that came from the reactant. And so you might notice that this is actually the opposite of the synthesis reaction, where remember, synthesis, we start with two different reactants and they combine into a single product. The opposite for decomposition, again, is that here we have single reactant goes to two or more products that were part of what we started with. And one example that we can use of this is the hydrolysis of water. It's actually a very simple experiment to do, that it only takes a battery and some wires and a beaker full of water. And so what's actually happening here is that the energy from the battery is splitting the water molecules that are in contact with this wire right here. So if you can imagine down at the molecular level, what's going on here is that we have water molecules here that are being split. Their chemical bonds are being broken from each other, and they're splitting into the individual elements. Here we have hydrogen gas as well as oxygen gas being collected in these tubes that are set into the whole experiment. And now we finally get to our combustion reaction, which you've heard this term before. Combustion is to set something on fire. So a very characteristic feature of our combustion reactions is that a lot of times there's fire involved. It's burning something. So to be more specific, we're taking some fuel in a combustion reaction. We take some fuel and it reacts with oxygen. This usually comes from the air. And what's interesting about this combustion reaction is that it always makes the same products. It's always carbon dioxide and water is the outcome of these combustion reactions. So just and there's something that you'll see for every combustion reaction where one of your reactants is oxygen gas, and through the chemical process, it forms carbon dioxide and water, H2O. So now we know that one of the reactants is oxygen, and we see that in our product size as well. There's two compounds that have oxygen. So now the only things we need for this is carbon and hydrogen. And so a lot of the times our fuel will be what is called a hydrocarbon, and this is just a compound that is made of both carbon and hydrogen. You can tell right from the name, carbon and hydrogen. Those are the two parts of a hydrocarbon. So this will become our fuel for the combustion reaction, and when it's in the presence of oxygen and enough energy, it will go through, it will burn, create a fire, and your product of this will always be carbon dioxide and water. Depending what type of hydrocarbon fuel you're starting with, you will get different ratios for all of the balanced equation, but it's just something that is a little bit more practice with balancing chemical equations, making sure that you have the right number of atoms on the reactant side as the product side. And just a side note on this one, you can also get combustion reactions with inorganic compounds. So that means that you don't have carbon and hydrogen. And so the process on this one is a little bit different, but generally you still always need oxygen for combustion reactions. Your products will come out looking a little bit different. Then this one, you won't have the CO2 and H2O because you don't have a supply of carbon and hydrogen. But really what's most characteristic about combustion reactions is the presence of oxygen as a reactant.